Good afternoon, everybody. It's a great pleasure to be here at Collision, a wonderful city of New Orleans. One of the questions I got asked a lot this morning, walking around talking to people, and I'm sure I'm going to be asked again, is, why are you here? What does NASA have to do with technology? Why is NASA at all interested in Collision? And I'll tell you my answer. It's very short. It's very simple. NASA deeply cares about technology because it enables everything that we do. NASA is a producer of technology, of course. We create things that are unique for our needs and missions in space and in the air. But we're also a big consumer of technology. We care deeply about new technology that's created. So if you've got new technology, and I know a lot of you do, please come find me afterwards. I'd love to hear about the work that you're doing. I'll start off by telling you a little bit about why we care so much about technology. If you think about the way that NASA has really tried to explore space over the decades, one of the things that's interesting is think about the state of the art of human planetary exploration. And this is it. Some of you may not have been alive then. I know many in this room probably were not. But in 1972, the last human mission to the moon took place. That was Apollo 17. Jack Schmitt, who's pictured here in front of the lunar roving vehicle, this still today, 46 years later, represents the state of the art of planetary exploration, at least human planetary exploration. A lot has changed over the past 4 decades. In fact, we now rely routinely on robotic spacecraft, satellites, orbiters, landers, rovers, to do exploration in places that we currently cannot send humans. A lot has changed in our understanding of how we create technology and use this for exploring planetary surfaces. And I think that one of the key things is, as we've taken this technology to new places, how can we then merge it with the human experience to look at future planetary exploration? So one of the things we've been doing at NASA for the past several years is trying to understand how you can combine humans with robots. How do you build human-robot teams for space? Part of this is because we're interested in allowing humans to work with systems that become more autonomous, robots that can carry out jobs by themselves. Part of this is that we're trying to figure out how humans can support these robots, because try as we might, our robots today can't do everything. They can't handle the anomalies, the edge cases, the corner cases, those things which pose problems to autonomous systems. And so one big question that we're facing is how can we combine them together in ways to allow the overall team, the human and the robot team, to be very successful. So one of the things we've been doing is trying to study different future mission concepts. One concept we've been looking at is the idea of having astronauts in orbit, whether they're in orbit above the moon or Mars, operating robots on the surface. Now, those of you who are fans of science fiction might recognize this as well. That's exactly the kind of thing that we saw in Avatar the movie. So instead of just relying on science fiction, Avatar the movie, we're trying to understand, can we put this into practice in real life? Can we have Avatar in real life? But to do that, we're not thinking about taking a person, fully immersing them inside of some virtual reality. We're trying to start off a little bit simpler, and that is the idea of having humans in a spacecraft, for example, inside the space station, operating through an interface which might run on a laptop or other computer system, and operate with a robot, say a planetary rover that's on the surface. A few years ago at NASA, we started looking at this concept. We did some testing with 3 different astronauts on the space station. It was a lunar mission simulation. If you're interested, if you're a space geek, come find me afterwards. We'll talk about all the details. But the basic point here is that we tried to understand what it took to allow humans inside a spacecraft to operate a planetary rover.
Prepared to command a robot on the ground in California. That's part of the Surface Telerobotics investigation, looking into how the human crew on board an orbiting vehicle can command robots, which are hundreds or even thousands of miles away on the surface of a planet or asteroid or the moon, in order to have those robots perform tasks that will help the people explore those places.
So what you saw in that short video, which was very quick, was an astronaut inside the space station. For example, this is Chris Cassidy, who was the Expedition 36 commander on the space station back in 2013, 2014, working with an interface that ran on a laptop. This is just a regular off-the-shelf, this is a Lenovo ThinkPad. It's running an application that was written in Java. It's running inside of an Eclipse framework, technology that we all use and have come to rely on for a lot of things here on Earth. It's sitting here running on the space station, allowing an astronaut who's had very little interaction with the robot to be able to operate it and to work with it. What we had Chris do was spend some time operating this robot. It was called K-10, to do things like surveying. So this was an outdoor test area we have at NASA Ames in California. It's set up to be like a planetary surface. It's not meant to be a full recreation of the moon or Mars, but it allows people to operate different mission simulations. And Chris used this robot to carry out a survey. We then had a second astronaut, this is Luca Parmitano, who's an Italian astronaut, working with K-10 to deploy a simulated radio telescope. And one of the future concepts involves rolling out long stretches of Kapton film. So here is the robot operated by Luca Parmitano laying out that film. We then had a third astronaut after it's been deployed to inspect that. This is Karen Nyberg, American astronaut who uses the same system, the same interface, running again on a laptop to operate the robot. Now what's interesting about all of this here is that the interaction here really is human-robot as a team. And the question is, what is the right way of controlling that robot? What's the right way of interacting with that robot? All three astronauts here worked with the robot in a very supervisory level, a very high level of control. They weren't joysticking, they weren't doing real-time control, but they're rather working at a higher level, more abstract level, in the same way that you and I would work together. I mean, I don't reach out and just try to joystick a person. I'll talk to that person. I'll try to really work more as peers, more as partners. And that's what we were trying to get at with this overall test. Now, one of the interesting things about this is if you think about it, the idea of an astronaut working from space to a robot really focuses then on those things that humans are good at, but that robots are not. And so, for example, during this operation here, and again, this is Luca Parmitano, what he's doing is monitoring the system here. He's watching how the robot drives over time. And his interface here is showing him, let's see, this laser pointer works here, it's showing him what the robot thinks of the environment. The red areas are areas it considers to be hazardous. Maybe there are rocks, maybe there are holes in the ground, maybe there are things that the robot just can't deal with. He's seeing that it's going to be moving to this location, it's turning, and he's monitoring that. And he's prepared to jump in, but only when necessary, only when the robot has problems. This is a really interesting thing, the idea that you're only interacting with the robot when it needs help, rather than being in control all the time. The idea that you can work together more as a team rather than just someone who's just joysticking. And the interesting thing for us is that after we did this work here, we started looking at other situations, thinking about how could this basic approach, the idea of a human and robot team, be applied here on Earth. And one of the things that we started thinking about is maybe we could take the same approach and apply it to one of the biggest areas of technology development today, which is self-driving cars. As those of you, who've run into these cars have seen, these cars aren't perfect yet. In fact, I'm not even sure when they will ever be perfect. They will often run into situations that are difficult because we as human drivers also run into the same sort of situations. Unknown situations when maybe the road is closed, maybe there's construction, maybe their signs are confusing. And in these situations, which are very difficult for humans by themselves to deal with, we know are even harder to make cars deal with by themselves. And so we thought it would be really interesting to think about how you could apply the same principles that we used for space to work with self-driving cars. For example, you might have visualization, again, using the same sort of interfaces that we used on the space station to show different things. This might be a construction site. You might have pedestrians walking across. You might be able to then provide some high-level guidance that said, well, it's okay in this situation to drive on the wrong side of the road, to basically break the law for a short period of time to really get through this difficult situation. And it was an interesting thing for NASA because, as I said, NASA is both a producer and a consumer of technology. For us, the key question is, why would people care about this? And how could we really work together with the people in the self-driving car industry to take the technology we've developed and apply it to problems here on Earth? And one of the things that's interesting is if you look at the comparison between what NASA does, the kinds of missions that we run in space, and the kinds of environments that you see being addressed by people who are working on self-driving cars, is there are some differences. I mean, obviously, NASA cares a lot about operating in natural and time-delayed environments, trying to work on the surfaces of places like Mars, trying to work in places that require a lot of onboard autonomy, but also ground supervision. These are very different sort of characteristics than we see with the self-driving car world, where maybe it's a more structured environment, like a road network is very structured, and that you have other concerns in terms of like cybersecurity for a large-scale consumer product. But the interesting thing, if you think about this, is that there's still a lot of overlap between these. NASA cares a lot about technologies that are common to both situations, both in space for planetary exploration, as well as here on Earth. Things such as autonomy, and I know there were some talks earlier today about autonomy and the impact that autonomy is going to have on our world and our workforce. Part of it also has to do with technology that supports human autonomy teaming. A lot of what we've been doing has really been trying to improve the way that humans can work together with autonomous systems. And there are other things too in terms of network operations, sensors, verification, validation. All those common things are cross-cutting. These are things that NASA has cared a lot about for space, and we've been trying to find ways to apply this to Earth. So for the past 5 years or so, we've been working with a number of different organizations. We started working with Google back in 2014. Shortly after that, we started working with Nissan North America to try to apply some of NASA's technology that was developed originally for space to problems here on Earth. Part of our interest is driven by the fact that we want to understand in real-world situations on Earth, in situations where there's perhaps the ability to do more testing than we can do in space, what are the key lessons learned, what are the best practices, what are the directions that's important to develop technology. We're also interested in trying to mature the technology here on Earth so that we can then reapply it back in space. So if we can understand how to really make humans team well with self-driving cars, we can then turn that around and apply that to humans, astronauts teaming with robots in space. So let me show you a short video here that kind of illustrates some of the work that we've been doing. This actually comes from our partners at Nissan North America and really illustrates how we've been applying some of this technology to Earth.
It's one small step for man, one giant leap for mankind.
NASA is recognized as the pinnacle of human endeavor.
Columbia, this is Houston, AOS, over.
The technology NASA has developed for space exploration has benefited society for many, many years. This technology that then gets developed can be used for autonomous vehicles to solve problems that we face here on Earth. It will be impossible to have fully autonomous vehicles driving around without ever needing help. Any autonomous system is built by humans, for humans. The vehicles will have to interact with human beings. And to do that well, and to do that in any situation flawlessly, we have designed a system for seamless integration into human society.
SAM stands for Seamless Autonomous Mobility. And what it is it's a system of support for autonomous vehicles and for transportation systems.
It's like the air traffic controls thousands of airplanes in the air with pilots in the cockpit, and still we have humans at a distance controlling and observing the airspace.
SAM is going to help us accelerate getting autonomous vehicles on the road by helping us deal with really unexpected situations.
Several cameras, LiDAR technology, as well as many other onboard systems assess the situation and build a picture of the world based on the best parts of each sensor. That's what we call sensor fusion. That picture is transmitted to the mobility manager, who then paints a new path around the obstacle. The vehicle can then safely follow that path and continue on. Once this new path is set, artificial intelligence in the cloud will distribute this to all the other vehicles to solve the same problem without the human in the loop. The next autonomous vehicle traveling down the same road will maneuver around the obstacle without any assistance from the mobility manager. However, SAM doesn't just solve problems. Its bigger purpose is to provide a complete system of seamless mobility.
I hope what you've taken away from this is that some of the work that we did 4 or 5 years ago, the idea of astronauts working in space, interacting with a robot here on Earth, is exactly the same way that we're talking about interacting with autonomous vehicles, self-driving cars, autonomous drones. The whole concept here is the idea that humans and these autonomous systems, whatever kind of robot you might have, can really work effectively as a team. That's what we started working on a few years ago with Nissan North America. We continue to work with them on some other technologies that we've been developing at NASA and are trying to then apply to other problems here on Earth. Now, one of the interesting things, as I said at the very beginning, is NASA is both a producer and a consumer of technology. And here at Collision, obviously, there are a lot of people that are trying to develop new technologies, trying to convey this to people for different applications. I want to convey to all of you who are producing technologies that NASA would love to hear about your technology. One of the things that we have is a very active small business program. The SBIR STTR program is one of the largest across the federal government. If you have new technologies, if you're a small business, NASA is very interested in seeing, can we make use of your technology? But one of the core things that you should understand is it's very important to understand what is the NASA relevance before just coming up and saying, hey, I've got technology, can you use this? I think it's very important for you to understand that we do want to use technology, but we want to be able to apply it in particular to addressing NASA-specific needs. And so coming out and talking to people like me and others at NASA is a very important part of that. If you're also somebody who develops technology that's meant to really reach out across the world, for example, you develop open source technology, we care deeply about that as well. because one of the core things is that we don't want to be the only customer of your technology. We want there to be a vibrant ecosystem that really is supporting your technology, really helping it flourish so that, that we and others can make use of it over the long term. Another thing that's interesting for you to know is that NASA licenses a lot of our technology. We produce a lot of software, for example, many of which, in terms of packages, are released under open source licenses. At NASA Ames, for example, my group has been working on robotics software for many years. Most of our software is now available open source, and it's available under permissive licenses, Apache 2, for example. We're trying to push this out in licenses that are well understood, that can be used by anybody who's familiar with open source technology. And the last thing that I'll just close with is to point out to you that if you're not a small business, if you're not just looking to consume, produce software for NASA, but you're really interested in being able to partner with NASA, we do a lot of partnership development, a lot of partnerships that we carry out day in and day out. For us, it's a really core part of what we do. If you're interested in working together with NASA, if you're interested in helping develop new technology that can be applied to future space exploration, please contact me, come find me afterwards. I'm here today and tomorrow. I'd love to hear from you. And that's all I have to say today. Thank you very much. Enjoy the rest of the show.